Hi everyone, Miss Vanessa is back, so let's learn science once again. But before we proceed with our next lesson, let's have a short review about our previous lesson. Now last time, we have learned about the atomic structure, right? And many other things about it. Now, as we have said from last time, do you still remember how an atom looks like? Right, this is how it looks like. It's circle with some other subatomic particles inside. And the atom is divided into two major parts, right? This part is called, very good, it's called the electron cloud. And in the middle, it's called as, right, it's called as nucleus. And as you can see, inside the atom, there are three different subatomic particles, the yellow ball, the green ball, and the red ball on this photo. Do you still remember their names? Let's start with the yellow one outside. What is this? What is the name of this particle? Very good. It's called as electron. And electron has a charge of? Right, it has a negative charge. Now, the next one inside of the atom is the red colored subatomic particle, as you can see. Do you still remember the name of this particle? Right, it's called proton. And proton has a charge of? Very good, it has a positive charge. Lastly, we have the last subatomic particle, also found in the nucleus of an atom, and it's called as? Very good, neutron. And neutron has a charge of? Very good, it has no charge. So this is how an atom looks like. Please remember them. Now, these atoms, we have many different types of them, and the different types of them is found in, very good, it's found in the periodic table of elements. Do you still remember how many atoms or elements we have in the periodic table? Right, we have 118 elements. Now, example of them is this one. This is what we call as magnesium. There are different other elements, and each of them is represented by their own different blocks in the periodic table. So we have one for carbon, for oxygen, for nitrogen, for hydrogen, for iron, and many other things. You can just look at your periodic table. Now, this name is what we call as? Very good. It's the chemical name or the name of the element. And this name of the element is accompanied by this letter. For magnesium, we have Mg. What do we call Mg? Very good. It's called as the chemical symbol. And the number at the top is called as? Very good. It's the atomic number. And the number below is called as? Very good. It's the atomic mass. Now, this information in every block of the periodic table gives us also information regarding the atom, as well as how many subatomic particles they have in their atom, right? So, if you remember from our last lesson, we have said that the number of protons is equal with the number with the atomic number. Okay, so if we're in this example, we have atomic number 12, then therefore, how many protons does it have? Very good, it's also 12. Now, in order to get the number of electrons, we have to remember that all the elements in the periodic table are assumed to be neutral. And when we say neutral, the number of protons is equal to the number of electrons. So, therefore, the number of electrons is equal to the atomic number. So, if there are 12 protons in this example, then there should be 12 electrons as well. Now, on the other hand, to get the number of neutrons, we have to subtract or minus the atomic mass from the atomic number. or atomic mass from the number of protons or the number of electrons, because as we have said, the three of them are equal anyway. So, but don't forget, it's only in a neutral atom. Now, 24 minus 12 is 12. Very good. So in this example then, the element, which is magnesium, has 12 protons, 12 electrons, and also 12 neutrons. Now, are you ready to answer the homework I gave you last time? Very good. So let's have a look. Let's answer together, and you can check your own homework. So, first question is, name the three particles of the atom and their respective charges. What are they? Right, we have proton with a positive charge, electron with a negative charge, and neutron with no charge. Now, the number of protons in one atom of an element determines the atom's number of protons, the atom's atomic number, and also the number of electrons, on the other hand, determines the blank of an element. Very good. It's the charge, because as we have said, if the atom is not neutral, if it has less electrons, it would be negatively charged, and positively charged, and if it has more electrons than the protons, then it would be negatively charged. So, next, the atomic number tells you the number of protons. Very good. In one atom of an element. It also tells you the number of protons, atomic number, are equal to, very good, electrons in a neutral atom of that element. The atomic number gives the identity of an element as well as its location in the periodic table. So no two elements will have blank atomic number. Right, no two elements would have the same or similar atomic number. Each of them, if you look at your periodic table, have their own atomic number. Next, the blank of an element is the total number of protons and neutrons. It is the mass number. Very good. And these are in the blank of the atom. Very good. It's in the nucleus of the atom. Now, the mass number is used to calculate the number of what subatomic particle? Very good. It's the neutron. In one atom of an element, in order to calculate the number of neutrons, you must subtract the blank from the blank. The mass number from the atomic number. Very good. By the way, if your answer is atomic mass instead of mass number, it's correct. It's still the same. So now, we have to complete the information on the table. Question number 1 is, givens are atomic number 12 and number of neutron is 12. Remember, atomic number is equal to the number of protons and the number of electrons, whereas neutrons, you have to subtract atomic mass from the atomic number or any of these two. So, for number 1, if there is atomic number 12, proton and electrons are also 12. And if there are 12 neutrons and atomic number is 12, 12 plus 12 is 24. So mass number is 24. Looking at your periodic table, what element is this? Right, it has the symbol Mg and the name is magnesium. Now number 2, since atomic number is 30, then therefore the element also has 30 protons and electrons. And the number of neutrons is 65 minus 30 is 35. Very good. What element is this? It has the symbol Zn and it's called as zinc. Very good. Now next, atomic mass, number of electrons is 35. Then therefore, number of protons and atomic number must be 35 as well. And neutrons would be 80 minus 35 is 45. So, checking your periodic table, this element has the symbol Br and its name is? Very good, it's bromine. Next, number of protons is 13. Then therefore, it must have atomic number 13 and number of electrons is 13 as well. Atomic mass on the other hand would be 14 plus 13 is 27. Very good. And this element has the symbol Al. What element is this? Very good. It is aluminium or aluminum. They are the same. Now next, the name of the element is uranium and the number of electrons is 92. So from the given electrons is 92, then possibly atomic number and number of protons are also 92. Symbol of element for uranium, the symbol is U. Now, if you check in order to get atomic mass and number of neutrons, since they are both missing, you have to check the periodic table. And in the periodic table, atomic mass of uranium is 238. So 238 minus 92 is? Very good, it's 146. So it has 146 neutrons. Now next question is, the atom has atomic number 11. Then therefore, its protons and electrons are also 11. Now the atom has number of neutrons which is 12. So therefore, 12 plus 11 would be 23. That is its atomic mass. And this element with atomic number 11 has the symbol Na. And the name of this element is? Very good, it's sodium. Now next, we have number of protons is 47 and number of neutrons is 61. So if protons is 47, possibly atomic number and number of electrons are also 47. And for its atomic mass, 47 plus 61 is? Right, it's 108. And this element with atomic number 47 is? Has the symbol Ag, and the name of the element with the symbol Ag is silver. Now next, this element has the symbol Hg. This element's name is mercury, and as you can see, atomic number is 80. Then therefore, protons and electrons must be 80 as well. Now, atomic mass for number of neutrons, atomic mass minus 80 is 121. Very good. Now, next we have number of protons as 53. Then therefore, atomic number and number of electrons are also 53. The number of neutrons then would be 127 minus 53 is 74. Very good. And this element whose atomic number is 53 has the symbol I and with the name iodine. Now last, we have potassium, and its number of neutrons is 20. And finally, it has number of electrons which is 19. Now, if it has 19 electrons, then therefore, its atomic number and number of protons must be 19 as well. And atomic mass would then be 20 plus 19 is 39. Very good. And the symbol for potassium is, looking at your periodic table, it is? Very good, it's K. So hopefully you got very good score. Isn't it just easy, right? So now, let's proceed with our second lesson. Our second lesson is everything about the periodic table of elements still, because the periodic table of elements gives us a lot of information about these atoms and about these elements, okay? We will go deeper into that as we go on with our lesson. Now, before we start, please remember you have to have a periodic table with you when you are studying with this subject, okay? Okay, now, who made the periodic table? So, as you can see from the name, he is called as Mendeleev. He is the last scientist who have tried to arrange the elements in different ways, as you can see from the periodic table. So, in 1869, Dmitry Ivanovich Mendeleev, who is an Italian scientist, created the very first accepted version of the periodic table, and he grouped the elements according to their mass number because he found out that every element has different mass. But right now, we are grouping the elements according to their atomic number, okay? And each of the elements are divided into families or groups, and these families, they have the same chemical properties. And during that time, there are still very less elements that were discovered. So Ivanovich Mendeleev left blank spaces in order to give space for the atoms that would be discovered or probably could be produced. So this is how Ivanovich looks like. Oh my gosh, so slow. Okay, anyway, so this is how the periodic table looks like, okay? Well, anyway, you know it already because you have it beside you, right? So, on Earth, the most abundant element is oxygen, okay? From the example, you could see we have 46.6% of oxygen on Earth, so we have a lot. And aside from that, next to it is silicon, which is 27.2. Now, this is why many of the rocks on Earth forms what we call as silicate rocks. When we say silicate rocks, these are rocks that contains both the elements which are silicon and oxygen. So we have oxygen, silicon, we have so much of them. Next is aluminum, we have iron, and so on and so forth. So as we have said before, there are many information that we can get from the periodic table. It tells us how the elements behave, in what state it could be, like is it solid, liquid, or gas, and many other things, okay? And one of them is that the elements are arranged in different ways. So each of them has their own atomic mass and also have their own atomic number. And aside from that, each of them has their own, very good, they have their own symbols. Now, for example, we have carbon and copper. Carbon, if you look at the periodic table, has a symbol which is C, while copper has a symbol which is Cu. Now, remember, all the elements have their unique symbol, and they consist either of a single capital letter, for example, carbon, only one letter in big letter, or it could be 2 letters or 3 letters, for example, for copper, with a big letter C, starting from a big letter C. Next is a smaller letter, which is, for example, U. Now, these are some examples on how did we get these elements, okay? There are some rules given in naming or in giving symbols to this element. So one is that the first letter of the name of elements is used and written in capital letter. So example, we have hydrogen, symbol is H, nitrogen, symbol is N. We have oxygen for O, and sulfur is S. So one, the very first letter in the name is usually its symbol. written in a big capital letter. Now next, if the name of two or more elements starts with the same letter of the alphabet, then the element is given a two-letter symbol where the second letter is written in a smaller letter. So for example, look at this example. Boron, bromine, barium, and bismuth. All of them starts with letter B. So we cannot give them just the symbol B because you would be confused which is which, right? So aside from the very first letter, we have to write or accompany it with a second letter, usually written in small letter. Now, usually this second letter is either the second or the third letter on the name of the element. So for example, boron is the letter B. It's given the letter B symbol because it has the lowest atomic number. It's atomic number 3. We have bromine is Br. We have barium is Ba. And Bi is bismuth. Okay? So because of this, it's easier to identify which element is which. Now the third one is symbols of some elements are taken from their Latin names. So when we say Latin names, these are their very old names because some of them has been discovered earlier before. Okay? Now for example, we have sodium. Sodium symbol is Na. That's because its Latin name is natrium. And then for silver, its symbol is Ag because its old name is called argentum. For iron, we have Fe because its Latin name is ferrum. And for mercury, we have Hg because its Latin name is hydrargyrum. Okay, now these are some more examples of symbols of some elements. So nitrogen, nitrogen N, sodium Na, chlorine Cl, carbon C, cobalt, potassium is K, copper is Cu, hydrogen is H, helium is He, iron is Fe, and many others. So all of the other symbols for each element, you can check on your periodic table. Now next, before we proceed more, let's learn some vocabulary lesson for our main topic for today. So these are some English words that you might encounter as we go on with our topic together with their meaning, and also I'll give you their Thai term or their Thai translation. So we have brittle. Brittle means something breaks easily. So for example, glass or a cookie. Okay? So in Thai, that's it. Chemical property is the property of an element material that becomes evident or could be seen when a chemical reaction has taken place. So for example, in Thai, this is the translation. Now, for example, a paper. When you burn a paper, it changes into ash and smoke. And ash and smoke have different properties or different from the original paper, right? That's chemical property. Now, conductor means the material can allow electricity to pass through. That means they can be used as wires. So, for example, copper, silver. In Thai, it's this one. Corrosion. When we say corrosion, it is the gradual destruction of a metal when they are exposed to water or has reacted with some other elements, and that makes them get destroyed or form a chemical reaction or form a rust. Okay, that's corrosion in Thai. Now, ductile. Ductile is the ability of a material to be stretched into thin wires. So some materials you can stretch into wires, and that ability is what we call as ductility, or the material is ductile in Thai. Next is dull color. Dull color is a color that is not bright or shiny, okay? For example, black, gray, white, yellow, red, blue. So those are some examples of dull color. Remember, they are opposite of shiny. They are not shiny. They don't reflect light. So that's the translation in Thai. We also have electricity. Electricity means there is the flow of charge. So electricity is flowing. Okay. Next, we have heat. So the flow of energy from one object to another because of their difference in temperature. So heat flows when there is a difference in temperature. Usually it is from hot to cold. Okay. Now next we have malleable. When we say malleable, it's the ability of a material to be pounded into thin sheets. So you can hammer something or press something to make them very thin. Okay, for example, copper, you can make it into a coin, a thin coin. Aluminum, you can make it into aluminum foils. That means malleable is the ability to become thin. Okay, in Thai, that's it. We have metal. Metals are usually, in Thai, it's this one. Metals are usually shiny and they can usually conduct heat and electricity. So that's why our wires are made up of metals. That's why our cooking materials are made up of metals. That's because they can conduct both heat and electricity easily. Metalloid, on the other hand, have both the properties of metals and non-metals. So we can call it as semi-metals. Okay, semi-metals. So some of them are good conductors of heat and electricity, while some of them are not. Now, non-metals is the total opposite of metals. Okay, non-metals are dull and cannot conduct electricity. Okay, usually, for example, cloth, paper, wood, what else? Brick. These are some examples of non-metals. Next, we have reaction. Is the process that leads the chemical transformation of a substance to another substance. So, for example, is reaction is when something comes up or the substance changes from one thing, from the original, into another thing. When it changes, that means a reaction had taken place. Okay? Now, lastly is shiny. Shiny usually is a property of a metal. Shiny means the ability to reflect light. That's why it shines. Okay? For example, is what else? Aluminium is shiny. Watch is shiny. Your necklace could be shiny. Your earrings could be shiny. Okay? So those are just some examples. Okay, now let's proceed. One way of arranging the periodic table is to know whether they are metals, non-metals, or metalloids. You would know them depending on their arrangement in the periodic table. Which elements are metals, which elements are non-metals, and which elements are metalloids. Now, for example, if you look at this example, you could see that they are arranged in 3 different colors, or the periodic table is colored in 3 different colors. So the green ones are the non-metals. We have here one that's alone, hydrogen. On the left of the diagonal are all metals. Most of the elements are metals. And in between the metal and the non-metal are the metalloids. So I'll give you time to color your periodic table based from the color of this found here, or you can color it depending on what color do you want. You can pause the video for now. Okay, so if you have color it, good, but if you don't want to color it, then you can just draw a diagonal line like this. Okay, so that separates metals from non-metals, and in between them is metalloids. So as you can see here, these elements that are inside the diagonal box is what we call our metalloids. How many metalloids do we have? We have 1, 2, 3, 4, 5, 6, 7, and 8. They are boron, silicon, germanium, arsenic, antimony, tellurium, polonium, and astatine. So these are the 8 metalloids on the periodic table. So aside from letting us identify which elements are metals, non-metals, and metalloids, another information we could get from the periodic table is to know the state of the elements. So this time, as you can see, the elements are colored according to their states. So what do we mean by states? It could be solid, liquid, or gas. So the periodic table helps us identify or determine which of these elements are in what state at room temperature. Okay, so we have 2 information now, which are metals, non-metals, and metalloids, as well as their states. Okay, blue colored blocks represents gases. Yellow colored blocks represents solids, while lastly, the red colored blocks represents liquid. So if we go back and draw the diagonal line we had before, which divides the elements into metals, non-metals, and metalloids, it will help us further understand easier the properties of the elements 2 ways already. Okay, so as we have said before, all the elements on the left hand side of this diagonal line are all metals, with the exception of only one element, atomic number 1, which is hydrogen. Hydrogen is non-metal. Please don't forget that. On the other hand, on the right hand side, these elements on the right of the diagonal are all very good. They are all non-metals. While inside, the elements inside this diagonal is what we call as metalloids. Very good. Now, as you can see, we have 2 properties information that the periodic table can give us now. Okay, their states, as well as whether they are metals, non-metals, or metalloids. Now, on the metal group, you could see that they are all yellow in color, right? The only one that's not the same as the others is mercury. So mercury is red. That means mercury's state is liquid. Mercury is a liquid metal at room temperature, okay? While the rest of them are all solids. Now, on the other hand, we have non-metals. Non-metals, as you can see, there are 3 colors. We have blue, gases. We have yellow ones, solids. And we have only one liquid. And that liquid alone is Br, which name is bromine. So most non-metals are gases. As you can see, this entire group are all gases, together with nitrogen, oxygen, fluorine, and chlorine, while the rest, such as carbon, phosphorus, sulfur, selenium, and iodine, are all they are all solid. Again, only one non-metal is liquid, which is bromine. Now, looking at the middle, we have the metalloids. Metalloids are all yellow blocks, which means they are all solids. Very good. So those are the states of the elements in room temperature or at room temperature. Now, let's go to the properties of metals, nonmetals, and metalloids. What are the differences in their properties? So this is an example of a metal. As we all know, metals are good conductors of heat and electricity. So both heat and electricity can easily flow on metals. This is the reason why our wires are made up of metals. Remember, they are made up of copper or either silver. And at the same time, our cooking utensils, our pans, our spoon and fork, they are usually made up of metals, right? That's because it's easier for the food to be cooked easier and faster. Okay? Now next, metals are shiny. They shine, they reflect light. If you look at the things around you, maybe you would identify which are metals and which are non-metals, right? So you have your necklace there, your watch, what else? Many other things. You just look around you. Now next we have ductile. Metals are ductile. That means they can be stretched into thin wires like this. So we can stretch metals very thin and very long without them breaking. So as I've said, that's the reason why we use them as wires. Now next is metals are malleable. That means they can be pounded into thin sheets. So you can hammer them, you can press them to become very thin. Example, look at this photo. We have aluminum foil. Very good. We have aluminum foil. You would see that aluminum foils are very thin, but remember, aluminum are metallic. We also have you know, the thin sheets that you stick into the Buddha, that's made of gold, right? Coins are very thin, but they don't break. Okay, so metals can be pounded into thin sheets without them breaking. Now another property of a metal is that their reaction with water. They have the ability to react with water, however, they corrode or they undergo corrosion. For example, iron. When you have iron or steel materials or things and you leave them outside your house and they are exposed into water and heat and what else? And moist or water vapor, right? They get rusted. Rust is an evidence of corrosion or a reaction with water. That means they get destroyed. Okay? And for them not to get destroyed, what you should do? Right, to paint them, because paint doesn't react with water. They are non-metals. Okay, next, high density. Metals are dense. They have high density. Usually when you put them in water, most of them, they sink. Okay? Next, they have high melting point. So from the word melt, that means it's hard for them to melt. They require high temperature, very hot for them to melt. Okay? And lastly, as we have said before, metals are mostly solid with the exception of mercury. Mercury is the only metallic element that is liquid. Next, we have non-metals. As we all know, non-metals are opposite of metal. So that means their properties are entirely the opposite of metals. So this one is an example of a non-metallic element. It's called as sulfur. Sulfur's color is usually yellow. Okay? This is the element that comes out of volcanoes and it smells bad. Now, non-metals are poor conductors, opposite of metals. So they cannot conduct heat and electricity. These two things cannot flow on them. Next, they are not ductile and malleable, so they cannot be stretched to become thin wires or can be pounded to become thin sheets because non-metals are brittle. They are brittle. That means they easily break into small pieces or they can be powderized. So look at this. This is sulfur. So as you can see, sulfur can be broken down into smaller pieces. Okay? Next, non-metals are dull. When we say dull, the color is not shiny. They don't reflect light. These are some examples of dull colors. We have yellow for sulfur, red for phosphorus, and black for carbon. It might seem like carbon here is metallic because it looks like it shines on the photo, but eventually in reality it's not shining. It's not like that. It's purely black, the same color as a coal. Okay? Next is many non-metals are gases. As we have discussed before, the entire last row is they are all gas together with other elements like nitrogen, oxygen, fluorine, chlorine. But some of them are solid, like carbon, sulfur, as you can see, phosphorus, they are solid. And the only liquid one is, do you still remember? Right, it is bromine. Now, opposite with metals, non-metals have low melting points. So, since most of them are gases, it's just easier for them to evaporate, or the ones in solid form or liquid form, same way, they only need low temperature to melt. Next, they have low density. Okay, so they are not heavy, they are light. Finally, we have the properties of metalloids. Metalloids has the property that is a mixture of both metals and non-metals. Okay, so example of a metalloid is silicon. Remember, we have how many metalloids we have? Right, we have 8. So metalloids have both properties of metals and non-metals. That's why we call them as semi-metals. Some of them are shiny, some of them are dull, but they are all solids. Don't forget that. And some of them can conduct heat and electricity, but some of them cannot. So it's eventually really in between. However, most of them are ductile and malleable. And as I have said before, they are all solid. Okay? I hope everything is clear. So now, let's have a small and short activity. Now, I'll give you the symbol of the elements, and all you have to do is to determine whether they are metal, non-metal, or metalloid. And at the same time, you have to give their name. Okay? So again, I'll give you the symbol. Nitrogen ang last. Okay, so let's have a short activity about what we have discussed. Okay? So this time, I'll give you the symbol of the elements, and using your periodic table, you have to determine whether they are metal, non-metal, or metalloid. And at the same time, you have to name them, okay? So again, I'll give you the symbol, and on the other hand, you have to answer or give us their name and identify whether it is metal, non-metal, or metalloid. So by this time, you can pause your video and I'll give you 5 minutes to answer this activity. Thank you. Okay, so let's answer them together now. So what is the name of the element Si? Very good. It's called silicon. And silicon is in what state? Very good. It's a metalloid. Next, Kr is the element. Right, it's krypton. And it is? Very good. It's a non-metal. Ba, on the other hand, is barium. And it is metal. Co is? Very good. It's cobalt. And it is also a metal. Next, we have P. What element is P? Very good. It is phosphorus. And phosphorus is? Very good. A non-metal. Now we have O. O is? Very good. It's oxygen. And it is? A non-metal as well. Finally, we have H. H is? Very good. It is hydrogen, and hydrogen is non-metal. Very good. Now, let's add some more, okay? Now, let's add, for example, the state. Let's answer together the state. Silicon is in what state? Very good. Silicon is solid. What about krypton? Right, krypton is gas because it's non-metal. Barium and cobalt are all metal, so they are both? Very good, they are both solid. Phosphorus, on the other hand, is? It's non-metal, but remember, non-metal could be solid, liquid, or gas. So, what now is phosphorus? Very good. Phosphorus is solid. Oxygen is? Right, it's gas. And lastly, hydrogen, which is a non-metal, is? Very good, it is gas. Very good. Now, this is the end of our lesson. So hopefully you've learned additional information this time. And in order for me to know whether you've understand what we have discussed, I will leave you with homework again. Once again, I'm sorry, but we will answer all of them together we will answer all of them on our next lesson before we start with our new lesson. Okay? So thank you. And you can copy the questions. You can pause the video in order to copy the questions. They are divided. It's divided into two parts. Part A is you have to complete the table. So we have a list of elements. You have to give it symbol, identify whether it's metal, non-metal, or metalloid, and finally give their physical state at room temperature. Part B is you have to identify again what is or are asked in the statements below. So we have 5 questions on this part and another 5 questions on the second part. So thank you, stay home, stay safe, and have a good day.